So in this video we will study about the secondary cells. So what are the secondary cells? Secondary cells are rechargeable batteries or secondary cells or secondary batteries. One example is this nickel metal hydride batteries are an example of secondary cell, and here is this reaction is shown for nickel metal hydride. Anode is nickel hydride, here M designate for metal. So for an example, nickel hydride, and so this is the oxidation reaction which is occur at anode, and the complex cathode reaction can be represented at nickel hydroxide. So basically this is also in alkaline atmosphere. So here we'll see how it look like. Basically nickel metal hydride batteries are become popular as rechargeable batteries. So you may have seen that rechargeable batteries are very common right now, and for an example here is this rechargeable battery which is says energizer, or let's see how much. So this is one example of the rechargeable battery. Another one is rechargeable battery is this car batteries or auto batteries which we use in our car, and this battery is called basically lead acid storage battery. Found in the car is a secondary cell where anode for the lead acid battery is the lead metal. So lead metal is this one. Lead metal when they have sulfuric acid in the mixture of in this battery, and lead oxidizes to lead ion and in case of cathode, lead acid battery is the lead oxide is the main cathode. So lead is anode and lead oxide is a cathode, and this reaction happen. Lead oxide goes to lead sulfate and lead also goes to lead sulfase. So in this oxidation, here this reduction reaction. So the lead acid storage battery consists of lead anode attempting with lead oxide cathode, all immerse in sulfuric acid. So this is the car battery. If you open somehow once, if you get a chance to see how it look like, basically there are different plates, and those plates are basically the form of lead, and they are submerged in a sulfuric acid which is a strong acid. And so when the car start, we use the battery, and when the car run, it keep charging also. So and once all the lead and lead oxide consume and there is no reactant remain, only product is there, lead sulfate, so we call the battery is dead now. So here is another example of this lead sulfuric acid battery. Lead grid filled with spongy lead. This is lead grid, and lead grid filled with lead oxide cathode, and here is this which is filled with the sulfuric acid as a electrolyte. So this was the second example, and then third example we have here, which is called the lithium-ion battery. They are also rechargeable batteries. So lithium cobalt oxide and lithium ion migrate from anode to cathode. So graphite is used as another electrode, and we'll see So here you have to understand that lead, lithium cobalt oxide used as a anode, and lithium loses the electron, and cobalt oxide used as a cathode. So in these type of batteries you have to understand and memorize these what reaction occur, or what is the main anode or cathode, and what reaction occur at anode and cathode. And here we have a comparison between the primary and secondary cells. This table says the zinc air battery. Here is the primary cells which are not rechargeable. Zinc air alkaline lithium battery. So energy density, energy storage, cost, safety, and environment. And then here we have a comparison of the secondary batteries, which is not very clear in this table. So here we have lead acid battery, lithium metal hydride, and lithium ion batteries for the energy density, energy storage, cycle life, cost. So this table shows the difference between the different type of batteries. And then next is important, we are going to understand about the fuel cells. So what is the fuel cells? Fuel cell is also a voltaic cells in which the reactant can be supplied continuously. So reactants are supplied continuously, and products of the cell reaction are removed continuously. So one side we are providing the reactant, and another side we are removing the reactant. And the most common type of this fuel cell battery is the hydrogen and oxygen gases to produce water. So when hydrogen gas and oxygen gas provide to produce water, it releases a lot of energy, and that energy is used as a battery. So oxygen is reduced at cathode, oxygen reduced to cathode to form water, and hydrogen is oxidized at the anode. So this type of battery is an example of electric car. So you may have seen that there are many electric car right now, and those electric cars, they use fuel cells to generate the energy and electricity to run the car. And here I would like to show you the limitation of the batteries. So limitation of the batteries: corrosion is a major cause of loss of performance in the batteries. That is why protective plating of material is used in the batteries, is an attempt to limit the performance diminishing effect of corrosion on the batteries. So you may have seen that even in the iron, if you have to protect iron from the environmental corrosion or rusting, we put the paint, right? So lead paint or some other kind of paint we paint. So we apply the paint which protect the surface of the iron. The same way corrosion is a major problem of the batteries. At certain point they start corroding the metals, and then there will be no more metals, so they lose the performance. So that is why non-corrosive paints are there, non-corrosive coatings are there, which we apply on the metal to protect their surface from the corrosion and rusting.